All right, so looking at absolute value equations. Let me erase over here. So if we want to solve the absolute value of 2x minus 3 equal to 11, we will use this principle that's in the red. If the absolute value of u is equal to c, then the way we would solve is we would examine or solve for when u is equal to c and when u is equal to negative c. All right, reason being is because of what's going on right here. We want to know when is 2x minus 3 equal to 11, when is 2x minus 3 equal to negative 11, because we have 11 in here, absolute value of 11 is 11. If we have a negative 11 in here, absolute value of negative 11 is still going to be 11. So that's why we have to take what's in your absolute value and set it equal to that value and then to its negative. All right. So that's what we do down here. We 2x minus 3 equal to 11, and then 2x minus 3 equal to negative 11. All right, so once you have established how you're going to solve and what you're going to solve for, you just add 3 to both sides. Those 3's cancel in both cases. I left out the 3 here. So in both cases, you add 3 to both sides. They cancel out on the left side of the equations. Divide by 2, and you have the two solutions of x equal to 7 and x equal to negative 4. All right. Questions? Any questions? Scroll up. All right. Next one, we have 5 times the absolute value of 1 minus 4x minus 15 equal to 0. So what we want to do here is isolate the absolute value symbol. We want to get an absolute value quantity by itself on one side of the equation. Then we'll be able to set it up this way. So we're going to add 15 to both sides. That'll give us 5 absolute value of 1 minus 4x equal to 15. Divide by 5. Now we have the absolute value of 1 minus 4x equal to 3. All right. So now that we have the absolute value of 1 minus 4x equal to 3, let me erase this stuff. We have 1 minus 4x equal to 3 and 1 minus 4x equal to negative 3. Set it equal to itself, then to its opposite. All right, now we can subtract 1 from both sides of each equation. 1's cancel on the left. Be 4x equal to 2, negative 4x equal to 2, and negative 4x equal to negative 4. Then divide by negative 4. We have our two solutions, negative half and 1. Any questions? All right. So the next one, we have a special case. Absolute value of 3x minus 7 equal to negative 21. So the key here is, or what you should be asking yourself, whenever you solve an equation, when is this equation true? So you're asking yourself, when is the absolute value of 3x minus 7 equal to negative 21? And the answer is never. Because the absolute value of a number is never negative. Remember, whenever you take the absolute value of something, the result is always positive. So the absolute value of anything is never negative. So that means your answer here is no solution. So be careful with that, because you can always put in work on this type of problem. And of course, you'll get the wrong answer because there's no work to do. Whenever you have the absolute value of a quantity set equal to a negative number, then the answer is no solution. Any questions? All right, so that's it. I believe that's it for 1.6. That was closing out 1.6. So before we get into 1.7, are we good? All right, so this is linear inequalities and absolute value inequalities. And this is our last section in chapter 1. Might finish, might not finish today. We'll see. So this first part is just distinguishing between the differences between your linear equation and your linear inequality. See if I can get it all messed up. Yeah, there you go. So you have x plus 5 equal to 7 versus x plus 5 is greater than 7. So our main differences here, we first see that the equation has an equal sign. The inequality has an inequality symbol. We'll look at all four of the ones that we will be using. But you have an equal sign versus an inequality symbol. That's the first thing that makes the distinction between an equation and an inequality. Second, when I solve this, and we will solve these the same way, there's one thing we have to consider when solving inequalities, but we'll get to that in a few. But all we would do is subtract 5 from both sides, whether we're dealing with the equation or the inequality. So in the first one, we see that x is equal to 2. That means we only have one solution, and that only solution is 2. Now, when I solve for x in that linear inequality, the statement that we will be left with is x is greater than 2. So that is considered a solution set because I want all of the values that are greater than 2. So it's infinitely many solutions. And like I said, all values that are greater than 2 will make this a true statement. So you're looking at this and saying, okay, when is this left side greater than 7? So anything greater than 2, whether it's 2.1, plug in 2.1 for x, that's 7.1. If you plug in 50, 50 plus 5 is 55. 55 is greater than 7. You can put in 1 million for x. That will make the left side greater than 7. So you want any value that will make this side greater than 7. And that's why you have an infinite amount of solutions that you can choose from in order to do so. So once again, one solution whenever you solve your equation, your linear equation, but you will get infinitely many solutions when you're solving your linear inequality. All right. Scroll up, are we good? All right. So our 4 inequality symbols that we will be using, we have the less than, then the less than with a bar under it is less than or equal to, greater than with a bar under it is greater than or equal to. All right. Next, we're looking at graphing and interval notation. There are going to be 3 parts or 3 possible parts to your answer. You have your solution set that we've already talked about, x is greater than 2. Then you will have, you can graph on a number line, and you will have interval notation, a way to express your answer or your solution set in interval notation. So if it's less than or greater than, we will use parentheses. That means we will exclude the value in question. We'll talk about what that means in a second. Less than or equal to, greater than or equal to will be a bracket. That means we will include the value. Negative infinity to positive infinity will always use parentheses. So anytime you have infinity symbol that you're using, you'll always use parentheses because you cannot include infinity because you can always go to the next number. So before I go down to the example, I'll let you copy that, make sure you got that. All right. So if we're talking about x is greater than 2 versus x is greater than or equal to 2, x being greater than 2, my solutions have to be greater than 2. That represents all values that are greater than 2, and 2 is not included as a part of the solution set. So that's what we mean by exclude. We will exclude 2. 2 would not be a part of the solution set. We want all values that are greater than 2. Now, if you say greater than or equal to 2, then 2 is included as a part of the solution set. So the parentheses versus the bracket, parentheses letting us know that we had the, the greater than symbol or the less than symbol, and that lets us know that we're not including that 2. But if I had the greater than or equal to, I would use the bracket, and that means I am including 2 as a part of the solution set. All right, any questions? Any questions? And over here in the black, this is the number line we'll be graphing on. Just emphasizing here, if I had number 1, everything to the right of 1 would be positive, would be greater than it. Everything to the left of 1 would be less than it. Even if I looked at number 2, everything to the right of it would be greater than it. Everything to the left of it would be less than it. So that will always be the case no matter what number you're dealing with. Everything to the right of it will be greater than it. Everything to the left of it will be less than it. So just examples of how we would have our solution set. We would solve for our solution set, graph on a number line, and then use our interval notation. And we're about to go through all of the scenarios in the chart next. But if I have x is greater than 2, I would put, for the number line, I would put parentheses around, not around, but over the 2, and shade to the right. Then if you look at going to interval notation, I'm going from 2 to positive infinity. And so that's reflected right here, 2 comma infinity. And I use parentheses, that same parentheses that I used here, I use over the 2. And remember I said you always use parentheses on the infinity sign. Same thing happens over here with the greater than or equal to. I'm shading to the right, using a bracket this time though because of the or equal to. And that's going from 2 to infinity, so that's 2 comma infinity. Bracket over the 2, and parentheses is always over your infinity sign. All right, any questions before we go to the chart?
Can you scroll back up to the purple words right quick?
Let me know where to stop, how far you want me to go. Right here.
Okay, wait, scroll back down. Just go to the example part.
Yep, let me know when you finish.
Okay, I'm finished.
All right. Anything else, anybody else before we go to this chart? Make sure we're good. All right. So notice in red, it says A and B are real numbers. They represent real numbers. If you notice in that first row, it says X is greater than A. Same thing as X being greater than 2 right here. It's just that we're putting an A there to represent any number versus just being specific to 2. So looking at the first 2 rows that represented what we just finished doing, you have X is greater than A. So you put a parentheses over the A and shade to the right. Then it means, and for your interval notation, you're going from A to infinity. Same relationship in that second row, it's just that we use a bracket instead of parentheses over the A. Third row, X is less than A. So this time we use the parentheses over A and shading to the left. And be careful here Notice the negative infinity is first because we read this from left to right. So we come from negative infinity up to a. So that's why it should be negative infinity, comma, a. Parentheses on both. Then the same relationship for that fourth row, using less than or equal to shading to the left, but we're using bracket over the a. So I'll let you copy those first four before we look at the next four. All right. Next four, we have three-part inequality, and you will solve one of those before we leave. But notice we have two numbers here, a and b. Remember, both of those letters represent a number. So what this is saying is that my solution has to be greater than a, but less than b. So those would be the values in between a and b. So you would shade in between a and b, use parentheses over the a and the b. For the next one, we have the or equal to that's attached to a. So we use bracket over a, parentheses over b. Then we have parentheses, bracket, because the bracket is right here, the or equal to is attached to the b. Still shading in between. And then for the last one, we use brackets over both. All right. Questions before we scroll up. All right, so there's one thing we have to consider that we didn't have to when it came to solving linear equations. So we want to solve linear inequalities. You must, if you have to multiply or divide by a negative number, then you must change or flip the inequality symbol. All right. I have to change or flip the inequality symbol. So just a simple, simple equation, not equation, simple example of an inequality in which that scenario would occur. If I have negative 3x, this was the original inequality, negative 3x is greater than 17, I would divide both sides by negative 3, and that greater than symbol would change into less than. So that's what we're saying here. If I multiply or divide both sides when solving by a negative number, the inequality must change to the opposite direction. So if it's greater than, it changes to less than. All right. Then you see on the right, I went ahead and did the other two parts. The graphing goes from the shading to the left, because we want values that are less than negative 17 over 3. So use the parentheses over the negative 17 over 3, shade to the left, and then negative infinity to negative 17 over 3, parentheses over both. Mm-hmm. All right. Questions before we solve some more? All right, so we're going to solve it the same way we would equations. Looking at this first one, 3 minus 2x less than or equal to 11. So we'll subtract 3 from both sides. 3's cancel on the left. Leave me with negative 2x is less than or equal to 8. Then right here, I divided both sides by negative 2. So once again, we're presented with that negative situation or scenario in which I divide both sides by negative 2. That changes my inequality from less than to greater than. So I have x is greater than or equal to negative 4. Now, if I want the values that are greater than negative 4, I'm going to shade to the right. And my interval notation would be negative 4 to positive infinity bracket over the negative 4. All right, questions? Any questions? All right, next one is x plus 3 over 4. It's greater than x minus 2 over 3 plus 1 over 4. So same thing would occur if we would do the same thing here as if I had an equal sign. I'll find the LCD, which is 12. And let me erase some things so we can walk through a little more. So don't forget that when you, after you find your LCD, then you're going to multiply each term by the LCD. So that's why I have 12 times x plus 3 over 4, 12 times x minus 2 over 3, and then 12 times 1 over 4. Multiply each numerator by the LCD. And what that's going to allow is for us to cancel the denominators into the numerator. 4 goes into 12, leaves us with 3. 3 goes into 12, leaves us with 4. 4 goes into 12, leaves us with 3. And then that gives us the result on that bottom line. 3 times x plus 3, 4 times x minus 2, and then 3 times 1. All right. Next move is to distribute. That gives us 3x plus 3 greater than 4x minus 8 plus 3. Oh, somebody said something in the chat. Oh, that was fine. That's fine. Combine your like terms. Let me erase some of this. We have a negative 8 and a positive 3 back here. So that'll give me a negative 5. So we have 3x plus 9 is greater than 4x minus 5. Now your goal should be to get all of your terms with x on one side, all of your terms without x to the other. And it doesn't matter which way you go with it. I'm going to take my 3x to the other side just because I want to show you something. And I'll add 5 to both sides. So the 3x's cancel here, 5's cancel on the right. And that will leave me with 14 is greater than x. I'm sure my math lab wants your variable on the left side. So this would be the answer that you would put in. So if you have to rotate, just make sure you flip everything properly. You know, if the mouth of your symbol is open towards the 14, then it should be still open towards the 14 down here. So, yeah. All right, any questions? So x is less than 14, so you want all the values less than 14 or to the left of 14, so you shade to the left using parentheses. And negative infinity to 14 is our interval notation, parentheses over each. Any questions? All right. Here we have a 3-part inequality. That's what those last 4 rows in that chart yielded to us. We want to solve for x. We want x to be by itself in the middle. So if that's the case, then we would, if we were trying to do so and this wasn't here, you would just subtract 1 from both sides. So we're actually going to subtract 1 from all 3 parts, canceling out 1 in the middle, leaving us with negative 4 less than 2x, which is less than or equal to 2. Then we divide by 2 from each part. And that will give us x is greater than negative 2, but less than or equal to 1. All right, so here go the other 2 pieces. You know, remember when we're dealing with this 3-part inequality and shade in the middle, we want the values that are greater than negative 2, but less than or equal to 1. So the values in between negative 2 and 1, parentheses over the negative 2, bracket over the 1. Same thing is reflected in our interval notation. You're going from negative 2, comma 1, parentheses over the negative 2, bracket over the 1. All right, one more thing and then we'll be done, but questions before we get there? All right, hold on 1 second. Yep. All right, so last topic in 1.7 is absolute value inequalities. So if you let U be an algebraic expression and let C be a positive number, says if the absolute value is less than C, then you're going to set it up. If the absolute value of U is less than C, then you're going to set it up as U is greater than negative C, but less than positive C to solve. But then if the absolute value U is greater than C, you set it up the same way you would in that green box, in which what's in the absolute value, that U will be less than negative C or greater than positive C. And the key here is that C is a positive number. That matters. That goes back to what we were talking about before, comparing absolute value to a positive number versus a negative number. And just pointed out right here that same thing goes for if you have the or equal to symbol. All right, so we want to solve the absolute value of x minus 4 is less than 3. So we have the less than symbol here. And so if you go to number 1, if it's less than, that's how you will set it up. So you take what's inside of the absolute value and you would do less than the positive 3 and then greater than the negative 3. So the middle quantity is our U and that 3 is our C. If you're comparing it to this right here. All right, any questions on the setup? All right, so from there you solve your 3-part inequality, add 4 to all 3 pieces. 4's cancel in the middle. And we have those 3 representations of our answer. Excuse me. All right, scrolling up. So now looking at this one, our original is 7 is less than the absolute value of 5 minus 2x. But if I want to compare it to what I have as options up here, the absolute value quantity is on the left side. So I rewrote it with absolute value being on the left side. So that gives us the absolute value of 5 minus 2x is greater than 7. So this means we actually have the greater than symbol. And as you go back and look at your greater than symbol setup, you would have 5 minus 2x is less than negative 7, and 5 minus 2x is greater than 7. All right, so from there, solve by subtracting 5 from each piece or each side and dividing by negative 2. Don't forget, when we divide both sides by negative 2 right here, our signs need to change. So the one on the left goes from less than to greater than, and then the one on the right goes from greater than to less than. So our two solution sets will be x is greater than 6, x is less than negative 1. All right. And then as far as your interval notation and graphs or graph are concerned, interval notation and graph, you have x is greater than 2, so greater than 6, so you're talking about shading to the right of 6. X is less than negative 1, so you're shading to the left of negative 1. So those will be your solution sets. Then you're looking at negative infinity to negative 1, parentheses over both. Use your union symbol that represents or, that's the same thing as saying or mathematically, and then 6 to positive infinity. So those would be your 3 ways of representing your solution sets. All right. Any questions? I think we have 2 more. We should be done. All right, so this next one, we have negative 2 times the absolute value of 3x plus 5 plus 7 greater than or equal to negative 13. So we want to isolate or get the absolute value of 3x plus 5 by itself. So the first thing we'll do is subtract 7 from both sides. 7's cancel. And that'll leave us with negative 2 times the absolute value of 3x plus 5 greater than or equal to negative 20. So don't forget the symbol doesn't change when you subtract 7 from both sides. But if we were to multiply or divide by negative 7, that's when our symbol would change. Which should happen next. I will divide by 2. 2's cancel on the left side, and that gives me the absolute value of 3x plus 5 is less than 10. Mhm. So it's not the answer, of course, but I think someone had asked me a question in between solving this problem. So I'm gonna come back to that middle piece. But if you follow the purple arrow, we're going right here. So we're looking at 3x plus 5 is less than or equal to 10. So we're right here. So don't forget, if it's less than, then we'll set it up this way. 3x plus 5 is greater than or equal to negative 10. Less than or equal to positive 10. So we subtract 5 from both sides. Not both sides, from each part. Subtract 5 from each part. And that'll give us negative 15,
Excuse me,
3x
I
in the
had a
middle.
question.
Yep.
Okay, so why'd you put the -10 in front of the sign again?
That goes back to just the simplest way to explain it goes back to here. When you talk about, oh, I didn't mean to press that. Hold up. All right. Right here. So that's 10 for us. So if you have 10, if it's less than 10, in this case less than C, you're going to do positive 10 and then do negative 10 on this other side over here.
Okay.
Yeah. So that's just going to be our initial setup. There's more background reason to why, but if you're just talking about just following the process and the procedure, this is it right here.
Okay, thank you.
Mm-hmm. And then just reemphasizing the other part of it, if it's greater than, then we will set it. We're still going to use a negative 10, it's just that our symbols, to be broken up would be different. So, all right, so go here. Is that it? Yeah, that's it. So subtracting 5 from each piece, that'll give us negative 15, 3x, and positive 5 on the right. Then divide by 3. I want to be red. 3's cancel in the middle. That'll give me negative 5 on the left, x in the middle, 5/3 on the right. And then here we have our two other pieces, or two other ways to represent our solution set. Negative 5 to 5/3 brackets over both, as far as your shading, and then interval notation. Once again, using brackets over both. All right, questions, very good, let's scroll up. All right, so going back to this piece, remember when you look at the setup, remember C was supposed to be positive. In other words, this number over here is positive. So if it's negative, you wouldn't follow this procedure. Remember we're talking about here, C being positive. If it's negative, we're going to look at this scenario. You're asking yourself, when is the absolute value greater than negative 5? And that's always. Remember we talked about whenever you apply the absolute value to a negative, to any number, the result is always going to be positive. So when is the absolute value of x plus 7 greater than negative 5? The answer is always. So the solution will be all real numbers. Then if you're saying when is the absolute value of 7 less than negative 5, the answer is never. So that means your answer would be no solution. There's nothing that you can plug in for x that will make x plus the absolute value of x plus 7 less than negative 5. All right. So if it's being compared to a negative value, then there's no work, just no calculation, just observation, and then application, right? So your absolute value will never be will always be greater than -5 or negative number. Absolute value will never be less than the negative number. All right, so once again, answer here is all real numbers. You can plug in anything, it'll be true. Answer down here, no solution. There's nothing you can plug in for X to make that statement true. All right. Questions, questions, questions. All right, so I believe that was the last one. Yep. So, that being said, that is it for chapter 1. Next class will be open for questions. I'm not looking to do any new material on next class, but the floor will be open for you guys to ask whatever questions you want to ask on the day for the whole class. So bring your questions. Some questions may not be generated until you actually get into my math lab, so take time out this weekend, get in there, see what type of questions are generated once you start messing around with these problems. And whatever you want to do, we can do. Any type of problems you want to see done over, we can do that on Monday. All right. Oh, also, I am going to, the Super Bowl is coming up this week, this Sunday. So I'm going to do something like, you get to pick a winner and probably maybe add 10 points to the test grade. So just be looking for emails. I know your selection will have to be made by Sunday around 6 or 7. I got to see when the Super Bowl starts. I think Super Bowls don't start till 8. So, just trying to add a little fun to the Super Bowl for us. Nothing mathematical involved, just more so just picking a winner, maybe picking a score, something like that. And but all the directions will be in the email. So if you don't even like football, nothing wrong with shooting a shot, just picking a winner. All right. So, but any questions on that? Any questions? All right. So if you guys are good, I'm good. Have a great weekend. Be safe, and I will see you on Monday. All right. Take care.
Thanks. See you Monday.
All right. See you on Monday.
Have a good weekend.
Thanks. You do the
Have a
same.
great weekend.
All right. Take care.